Hello guys, welcome to another episode of the Supermileage show. Let's get started. In today's episode, we'll be covering the sustainability segment and also the hands-on session with the motor. So what is the sustainability segment? Through this section of our show, we want to bring forth cool and new technology that thrives completely out of sustainable energy sources. So this means is that the technology under discussion would have zero or neutral carbon footprint. So what's in store for today? What are we going to talk about today? So today we'll be talking about supersonic flights. When was the last time we actually saw them in action? As far as I remember, the last Concorde flew almost like 2 decades ago. Why am I talking about supersonic flights in the sustainability segment of our show? Here's why. A company based in the US is actually claiming to roll out completely sustainable supersonic flights by the 7th of October 2020. Well, that's a month from now. So this firm goes by the name Boom Aerospace. They were founded in the year 2014 in the United States of America. So they set out on a journey that no other commercial freight carrier has ever done before. So what Boom Aerospace believes is that even though there's a lot of extensive research that goes in the battery propulsion for jets, they feel it's really viable only for short-term flights, that is regional flights basically. So when you're looking at inter-countries or intercontinental flights, that's the long-haul flights, the current battery technology that we have, they don't support the same. So they thought that sustainable fuels was the only way to make sure that they reach the target of long-haul flights. So what did they do for the same? For 6 years, that is since its inception, they've been doing extensive research in this field, not only in the sustainable fuel field, but also in various sectors of their industry to make sure that the supersonic flight, which is commercially viable, is completely sustainable as well. Not only in the fuel aspect, but also in the construction and everything. So last year, that's 2019, they actually partnered with Prometheus Fuels. So Prometheus Fuels is going to give the sustainable fuel to Boom Aerospace. How are they going to do so? So they're going to economically convert the CO2 present in the atmosphere into a fuel that is compatible for jet propulsion. So this is what Prometheus Fuels is going to do. And because it's a fuel that is made out of renewable energy sources, it's going to come under the sustainable means. Boom Aerospace always believed that there's a lot of firms, like almost everyone today, relies on carbon from non-renewable and fossil fuels basically. So they thought that if they could somehow grind carbon out of renewable energy sources, that is basically sustainable means, then they would be doing a lot to the sustainable development of their aircraft. So this is a journey that they set out on. If you see today, they're actually doing a really good job. Because when they initially set out, they just wanted to build history's fastest commercially viable supersonic flights. But that's not the case today. They're doing it with sustainable means. And in a month from now, we'll actually get to see their first ever program, the XP1. That's the name of the program. So it's completely carbon neutral. It runs on sustainable fuels like I mentioned. And the completely assembled body would be out on the 7th of October. We can't wait to see how that one goes. Now you guys must be wondering whether these aircrafts are actually safe and the commercial aspect of the same, and whether a person like you and me could actually afford a ticket on this. So to put things into perspective, actually when you see, these aircrafts cost about close to $200 million a piece. And it might seem like a high price, but they've already clocked close to $6 billion in pre-sales from Japan Airlines and Virgin Group. So it's not like no one wants these, everyone really wants these aircrafts. And when you look at the safety part, they come under the same safety norms and regulations of what every commercial aircraft today does. So the safety part is covered on that front. And the economical viability for a person like you and me, look, the founder says that the tickets might be priced close to the business class tickets that we see today in any other commercial air. So even that part is covered. So it's not like you have to pay a hefty sum just to go in a sustainable aircraft, and that was supersonic sustainable aircraft. So they're saying that the journey would be cut by half. So if you're saying there's a 12-hour journey, this aircraft would make it viable to travel in just 6 hours. So the aircraft design would be pretty simple. It won't be like how you see the commercial aircrafts. It won't be so huge. It would be anywhere between a 30 to 50 seater basically. And they won't be the arrangements that you see in a commercial aircraft. All of them would almost be very similar to the business class seats. and to give you the best experience, they would be of that sort. So even the journey is short, you won't have specific needs like the beds and everything, like how you see in big aircrafts today. And they're doing business with some of the top firms in the world. So for instance, Rolls-Royce actually works on the propulsion systems for Boom Aerospace. So they're directly dealing with them because Concorde, the last supersonic flight Earth has ever seen, Rolls-Royce worked for them. So Rolls-Royce is the only company in the world that is capable of working on these propulsion systems for Boom Aerospace. Now we move on to the next section of the show, that is the hands-on session of the motor. We have Abhijit to explain the same. Over to you, Abhijit.
Hello everyone, I am Abhijit, the electrical head of Team Inferno. In today's episode, we'll be taking a closer look at a brushless DC motor. Now, before I open this up and show you the insights, let me tell you the parameters of this motor. This is a direct drive 500 watt 48 volt in-hub BLDC motor made for e-bike based applications. Now, as you can see, there are a set of wires coming out from the insides of the motor. These are the wires that connects the motor to the motor controller. If you take a closer look at them, you can see that there are 3 thick wires and 5 thin wires coming out. The 3 thick wires are the phase wires. As we discussed in the electrical overview video, each of these 3 wires are responsible for 120-degree rotation. When the 3 wires are energized in a certain sequence, one after the other, the motor rotates. The 5 thin wires from the hall sensors, one for each phase, provides the motor controller with the position information based on which the control will decide the sequence. Now let's open this up and see what's inside. This is how the inside looks. I've removed the hub plate on one side so that we can take a look at the internal coils. What we have here is an outrunner direct drive BLDC motor. In BLDC motor, there are essentially 2 types of designs, inrunner and outrunner. In the design of this specific motor, this is the stator, the static part, and this is the rotor, or is the part that rotates. You can see that the stator is on the inside and doesn't move, while the rotor is on the outside rotates. And hence, this is an outrunner BLDC motor. Moving on, these are the poles of the motor. This is one pole, second, third, fourth, fifth, sixth, seventh, and so on. In this particular motor, we have 48 poles. On the end of these poles, we have the permanent stator with the neodymium magnets. These magnets are arranged one after the other in opposite poles. If this is north, this is south. North, south, north, and south. The other side of these are fixed to the hub walls using a strong heat-resistant adhesive. Here, looking closely, you can see that 4 poles appear to be in a group. These 4 appear to be together, these 4 appear to be together, and these 4 appear to be together, and this pattern continues. In the overview episode, we've named them as 1, 2, and 3. Because the total 48 poles can be simplified to 3 poles named 1, 2 and 3. So, here this can be 1, this can be 2 and this can be 3. The coil pack on the opposite side of these will be connected in series. The pack on this side is basically the same as the pack on the other side. So, the coil pack on one side is connected in series to this coil pack. The same pattern is followed by 2 and 3 as well. The idea of this is the total 48 poles are wounded in packs of 4 and each phase gets 4 packs. If you imagine that the 12 numbers on the face of a clock are the stator poles, then 1, 4, 7 and 10 would be combined into one of the phase group, and those 4 would be energized and de-energized at the same time. Following this pattern, 2, 5, 8, 11 would be the second phase group and 3, 6, 9, 12 will be the third phase group. Here I've completely removed the stator winding with the axle out of the enclosure. The high number of poles in the motor has several advantages. Probably the biggest benefit is that since the number of poles are high, the size of the stator magnets can be small and hence can increase the total torque of the motor. Added to this, The shorter magnets help in back iron being able to work properly while being much thinner, and that saves weight. While on the negative extreme, when a higher voltage is applied to the motor to make the motor spin faster, we may find that the high pole count motor to be limited in the electrical switching frequency, or basically how fast each phase has to be turned on and off when we use normal common controllers. And then there is the issue of eddy current losses. Eddy currents are too complex to fully explain here. Just know that for a very high RPM, you need thinner lamination and a lower pole count, or when a certain RPM is reached, there will be a sudden and seemingly unexplainable increase in the heat. Focusing on the pole shoe, we can see that this is made of thin laminated sheets of metal, exactly like in a core of a transformer. As we know, the reason why a solid iron core is not used in a transformer is to reduce the eddy and the hysteresis losses. Just like that, the laminated sheets are used here to minimize the losses. Now let's talk about the Hall sensors. We can see here that there are a total of 9 wires coming out from the Hall sensors, which basically means that the Hall sensor is a 3-terminal device. One terminal is the VCC, the second terminal is the ground, and the third terminal is signal. The VCC and the ground wires are common for all 3 sensors, and we have 3 output wires from the 3 sensors. That is why we have a total of 5, 2 plus 3 thin wires on the outside of the hub, which is connected to the controller. A Hall effect sensor is a device that is used to measure the magnitude of the current field. Its output voltage is directly proportional to the magnetic field strength through it. When the magnetic flux density around the sensor exceeds a certain preset threshold, the sensor detects it and generates an output called the Hall voltage. This voltage is measured by the motor controller and the required sequence is initiated. Well, that wraps up today's episode. Thanks for sticking till the end. Hope you found this episode very informative. If you guys have any questions, feel free to hit me up or leave them in the comment section below. See you all same time next week. Stay safe, stay inside.
So today, we'll be talking about industrial signages in particular. By signages, we're going to be talking about the process of making a signage. Because if one looks at a signage right now, they'll think that it's just picture and text put together. No, there's actually a lot of protocols that one has to follow to put up industrial signages in their workshop. So what goes into the making of the same? Even the text that you put out there, the picture that goes associated with that, the color that you're using, all of this means something. So what does a color code actually mean? Let's look at some colors that are usually used for signages, especially industrial signages. The first color, be it black and white. So these colors are usually used just for the text that's used in the signage and also the borders that cover the signage. So that's about the black and white. Next, moving up, yellow. All of us know that yellow is very frequently used for signages. What does this mean is that when there's yellow in the signage, that means that there's a physical hazard present. So yellow depicts that is a physical hazard. So one has to be careful on that front. When there's purple, which is usually rare on a signage, it means that your workshop is prone to radiation hazards. So one has to be careful on that front when you see the purple color. Other color is the blue. So if you're seeing some text in the blue color or in a blue part of the signage, that means that that is some important information that one has to read through before working in the specific workshop. So blue indicates important information that one should miss. Then the next one is the green. So the green color, as all of us know, it symbolizes safety, right? So that green justifies where the safety equipment goes actually in the workshop. So you'll know. So this green means that these are the safety equipment. You could actually use them safely without any care. And if you actually notice, there are norms for the size of the signages based on how far the viewer is viewing them from. So say I'm viewing them from a distance of 10 feet, then there's a certain size that one has to follow in making up or putting up the signage. Who decides all of this? As of now, everyone follows the ANSI and the OSHA. So these are two different institutions which work separately for especially for signages. So that's it for today, guys. Thanks for tuning in. Hope to see you next week with some other episode and some exciting new content. Until then, think, sketch and execute.